All right. Last kind of factoring we're going to talk about is factoring by grouping. So generally this is a strategy to use when you have a polynomial with four terms. Right, so here I got x cubed minus 5x squared plus 3x minus 50. Now notice there's nothing that I can take out of all four terms. Okay, I can't take an x out because this last term doesn't have an x. I can't take a 3 or 5 out because this first one doesn't have any coefficient except for 1. So what you're going to do basically in factor by grouping is you're going to group two of the terms together into each into two groups of two. So like I'm going to group the first two terms together and see what I can factor out of there. So out of x cubed minus 5x squared, I can factor out an x squared. Okay, if I take an x squared out of x cubed, I've got x left over. If I take an x squared out of minus 5x squared, I've got minus 5 left over. Okay, then I'm going to group together the second two terms. All right, what can you factor out of 3x minus 15? Well, you can take out a 3. Okay, a positive 3 in that case. So take out a plus 3. And if I take a 3 out, what I have left over out of 3x is x. And what I have left over out of minus 15 is minus 5. Now notice that after I do this, I've got two parentheses which are identical, x minus 5 and x minus 5. Okay? That's good. If you're doing it correctly, that's what should happen. All right? Now this next part's a little weird to understand, but what I'm going to do is I'm going to factor out again. Now notice basically what I have here is two things adding together, two kind of big terms. I've got this first term, x squared times x minus 5, adding to 3 times x minus 5. So since I got two terms, they each have one common factor, this x minus 5 here and here. So what I can do is basically take that entire term out front, that x minus 5, and what I have left over after I take out the x minus 5 is x squared plus 3. And I am done. Okay, so the basic strategy here is group the first two terms together and the last two terms together, take out any common factors you can, and hopefully if it works, you'll have the same thing in both parentheses, which you can then factor out, leaving you with your factored expression. In this case, x minus 5 times x squared plus 3. All right, so let's look at this next one. I'm going to group together the z cubed minus z squared, and I'm going to group together the minus 9z plus 9. So what can I factor out of z cubed minus z squared? I can factor out a z squared. So then what's left over? Z minus 1. Okay? Now, next thing I got a negative 9z plus 9. Okay? What can I factor out of that? A 9. Although I'm actually not going to factor out a 9, I'm going to factor out a negative 9. And the reason I'm factoring out a negative 9 is because, as you'll see here, I need to factor out a negative number to make the next parenthesis match z minus 1. Because if I take what's negative 9z divided by negative 9, negative divided by negative is positive 1z. What is positive 9 divided by negative 9? If I take like this 9 out, 9 divided by negative 9 is minus 1. So now these parentheses match up, where they wouldn't have matched up if I'd taken out a positive 9. Instead of I would have had a negative z plus 1. Okay, so now I can factor out z minus 1. So what I'm left with is z minus 1 times z squared minus 9. And I am done. Or am I? This one's kind of tricky because actually it can be factored slightly further. Look at the second parenthesis here, z squared minus 9. Guess what that is? That is a difference of two perfect squares. If you remember, difference of squares is a pattern that can be factored further. Like if you have a squared minus b squared, remember that can be factored into a minus b, a plus b. Okay? So what I can actually do here is break this one down further. So z minus 1 is going to stay the same, but z squared minus 9 is going to become z minus 3, z plus 3. And now this can no longer be factored anymore. Okay? So in this step, it wasn't actually wrong, it just wasn't factored completely. So you're done factoring when nothing else can be factored out or factored any sort of pattern. Okay, one last example down here. So I'm going to group the first two terms together, second two terms together. So out of 2x cubed minus 3x squared, I can factor out only an x squared. 2 and 3 are prime numbers. I can't take anything out of there. So if I take an x squared out of 2x cubed, I'm left with 2x. If I take x squared out of negative 3x squared, I'm left with minus 3. Okay. Now look at these next two terms. Can you take anything out of 2x minus 3? It looks like you can't. But even if there's nothing else, everything always has 1 as a factor. Okay? So what I'm going to do is I'm going to factor out a 1. Okay? If I factor out a positive 1, 2x divided by 1 is 2x. And this was a plus sign, by the way. It looks kind of like a minus sign where I drew my parenthesis. And then if I take a 1 out of minus 3, it's still just minus 3. You'll notice that 2x minus 3 was already what this parenthesis was, so just factoring out a 1 will be perfect. Okay, so now I can take out the 2x minus 3 and the 2x minus 3, leaving me with 2x minus 3, and the leftover is x squared plus 1. And I am done.